So we have a ball at the top of the building that we're going to throw straight up at 10 meters per second. We want to know how long it takes to hit the floor. So we have to consider the motion in two halves. Firstly, we'll find how high it goes. To do this, we write out the initial and ending conditions for this bit of the journey. Remember, of course, that we're going to take, by convention, positive to be up, which means that the acceleration, g, is negative, and the speed at the top of this part of the flight is going to be 0. It stopped moving. So we'll just use one of our Suvat laws there, put in the value of 0 for v squared, 10 for u squared, and then for our acceleration we have to remember that it's negative. Really important that you do that. Times it by s. S is what we want to find. Rearrange. Minus, you've got to take real care with your minus and positive signs with this stuff. Anyway, there we go. Minus 100 equals, I was reaching for the calculator. Here we go. This is a bit of a long gap. Minus a 19.6, 2 times s. Rearrange. Well, not really rearrange very much. Forget minus signs cancel out. So this means that it's going to go the total height of 100 over 19.62, which is going to be around about 5 meters. 5 meters. So the ball goes up 5 meters if it starts off at 10 meters per second under the influence of gravity. So next up then, you need to find the time that the ball takes to go to the top. In other words, how long does it take to go up to where v equals 0 or 5.1 meters? So this is v equals u plus at we're going to use. 0 meters per second at the top, so v equals 0. Put in the numbers, again, take care with that minus sign. Do some rearranging. We get 9.81 t equals 10. So that means that the time equals 1 second. Well, I'm just going to approximate here that that's equal to 1 second. So the next part then is to consider how long the ball takes to get back to where it started. Well, to get back to where it started is going to be simply up to the top, which is 1 second, and back down to where it started off, which is another 1 second, because it's symmetrical. Therefore 2 seconds. Right, so we now have the ball back where it started. Now look, I've decided to make positive go downwards for this third version of the Suvat laws. So the initial velocity is 10 because it's got back to where it started, but it's moving in the opposite direction at the same speed. We've got to do 2 steps here to find how long it takes to fall to the bottom. As you know, there's always more than one way to do these questions. So v squared is what we need to find first, or v I should say. So we put in u as 10, square it, times 2. This time we're taking 9.81, the acceleration due to gravity, as positive because we set positive equals down. This doesn't matter because we're just adding times together. This comes out, if you work it out, as 33 meters per second. We can now use that figure and put that into the equations for v equals u plus at to get a value for the time of flight from the top of the building to the floor if it starts off at 10 meters per second moving downwards, which it does. Rearranging and putting in the values gives us a figure of I'm going to just write it out. Okay, 9.81, it's all positive because it's going downwards, remember, and equals time, which is going to be, working it out, around about 2 seconds, 2.3. Okay, so now we need to get the total time of flight. Almost there now. So the total up to where it stopped, back to where it started, which we found out was 2 seconds, plus the time it takes to go from that calculation from the top of the building to the floor. Okay, and the total time, add those together,